There's no point really in me giving you this and saying differentiated and integrated back again. That's exactly like the problem X cubed we did in class. I mean, that has almost evolved to the point of being a college algebra problem. Well, not quite, but you know.
Like I said, I hear you.
So I was hoping with your mastery of computational technology that you would argue that x to the fourth cos pi over x is continuous everywhere. You need to show that. Then if it's continuous everywhere, it's Cauchy integrable on 0, 1. And if it's Cauchy integrable, it's a Riemann integrable. And then Maple does a Riemann integral. And there it is. And you'll notice that at 0, all of the, yes, it's undefined, but this kills everything, right? The only thing that survives is this, and that's 0 and 0 as well. Because the integral is from 0 to 0. Right? So it just goes away. There's no contribution at the lower end where the function is poorly behaved. There's no contribution. So you just evaluate that expression at 1. And that's where the minus 0.13 is. So are there other accumulated angst worthy problems? How about the one with the finite number of points where the functions differ?
Is that number 4?
Could be.
Yeah. Well, I have 2 answers. It didn't really look very much like, so it was cool.
Think of if they differ at a finite number of points, and you set up a Riemann sum for one function and then the other, f and g. How badly could they differ? They don't differ by very much as the partition norm gets smaller and smaller because you know the difference between the two integrals would just be the difference at those points where the functions differ times the length of the subinterval summed up over. Yeah, I mean if they differ at n points, let epsilon be epsilon prime over n. Right? And if you have n points. I'm just trying to make it clean so that you have an epsilon when you're done. You know, if you fix epsilon and then use 1/n of your epsilon to dominate the rectangular area at each of the n points where the functions differ, the two Cauchy sums will be within epsilon. And if two things are within epsilon of one another for any epsilon, those. Why is that argument true, by the way? Can I switch this now? No. Why is it that if we say for all epsilon greater than 0, x is less than epsilon absolutely implies x equals 0. That argument is used implicitly all the time. Why? How is that argument valid? You prove that? Why is that true? Suppose not. Which means what? X is not equal to 0. Then the absolute value of x is equal, say, to delta. Greater than 0, right? So choose, what shall we say? Epsilon equals delta over 2. Okay. Now remember, x is less than any preassigned epsilon. Absolute x. So you're saying absolute x is less than any preassigned epsilon. This thing is, I can get it to stay there. No, okay, that's good. X is less than any preassigned epsilon. Well, if epsilon is delta over 2, what's that? I lost my train of thought here. Oh, yeah. have a little problem. Right, that's a contradiction. The only thing that can possibly happen is X to be X is zero. Right? So that argument appears. I've expanded the article I put together there on the Cauchy integral. I'll post it this evening, but I put the two recovery theorems on it: the recovery of a function from its integral and the recovery of a function from its derivative. And we did it we didn't do those in class, but in class we did the convergence thing. I'll put that out there too. And then I guess I'll shut that one off and start the one on Riemann, which will, I guess what I'll do is recap main Riemann things, but not in quite so much detail when it overlaps what we did for Cauchy. A tremendous amount of what we did for Cauchy with Riemann. And I wrote up the continuous nowhere differential function. Did you see that? Okay. Did you guys understand that one? It makes more sense to me than Billings did. Anyway, if you read that closely, I went into extreme detail, and it's a strange phenomenon, really, continuous but nowhere differential. In that explanation, I used a couple of theorems that I think we should be aware of. So no more questions on the test, right? We're with everything else, more or less. We'll take a break, and I'll bring back the true-false things. The scores were extremely tight. The standard deviation was like 0. No, I think everybody's within 2 points. I think the scores went from like 45 to 47 or something. Great minds apparently think alike. Great minds study alike. I'm sorry, what?
Rob and I were going over true false at school that day, and number 3, that Riemann was Cauchy one that you.
I threw out 39, 41, and 3.
He was yelling at me because you gave me the wrong answer right after the class. I'm like, that's what it was.
I'm still searching for a function.
You're all the ones that think I got.
No, I think you have the high score from us.
Really? That would be a shocker.
Look outside there and see if Porky Pig is flying by.
And I'm sure it's still wrong, right? That would be a Friday minute.
I heard.
Really great. What did you email me? What language was that that you emailed me?
I think you get kind of a translator on it.
No. Oh, you know what that is?
No, I don't.
I just we have to have these disclaimers at the bottom of emails that say that this is intended for the certain recipient, and if you get it and you're not the named recipient, you should, beat yourself in the head with a sledgehammer so you forget, gouge your eyes out so you don't remember what has been written. So I decided I'd just write that in Irish Gaelic, just to screw with the system.
That's okay.
So I'm sorry if I've caused you any emotional discomfort there. I can.
No, I just wrote back to you. Thanks for the nice message. I have no idea what it said. The kind words of wisdom. I didn't know what it was.
All it says is if you're not the intended recipient, please disregard this message and treat it as fun.
I disregarded it.
Okay. All right. What the hell was I talking about?
So the theorems that you use.
Oh, yes, the theorems that we should all know. And let's see how good we are at proving. Oh no, I'll go get the. When I run out of coffee, I'll get another one. And I'll go get the true false. But I think she got the highest score. So, you go.